Hi, good morning, everyone. Thanks for joining us today. My name is Mansi Vyas. I'm from Mylan Foundry, and I'm the coordinator for today's webinar. I have about 8+ years of experience in M&E, media and entertainment, in this technology sales space. Today's topic of discussion is enhanced streaming security with forensic watermarking and AI-based upscaling. I'm joined by AI and tech experts from Inca PallyCon and Mylan Foundry. Without further ado, I would like to invite Mr. Harish from Inca PallyCon, who has about 16+ years of experience in technology. Hey Harish, would love for you
Hi
to say a
Mansi.
few words.
Hi Mansi. Thank you for this webinar. I'm Harish Bhatt, product manager at PallyCon. With a vast background with media and broadcasting. I have been working with almost a decade with the media and broadcasting industry and the networking company. And I'm associated with PallyCon for working on the forensic watermarking and anti-piracy solutions. Which are aimed or focused at protecting the streaming and OTT contents.
Great. Thanks, Harish. We also have Anusha joining us from Mylan Foundry. Anusha has deep experience in AI ML. Anusha, would love for you to say a few words.
Thanks, Mansi. I'm excited to be a part of this webinar. My background is in data science, AI, and machine learning. I've worked for a long time in this space, mostly on technology and product development. At Mylan Foundry, I lead all of the product and business initiatives for the media and entertainment vertical as a senior director. At Mylan, we solve challenging problems in the area of video, images, and text data using AI, and particularly specializing in deploying AI models on resource-constrained edge devices.
Great. Thanks. Thanks so much, Harish and Anusha, and for the introduction and taking out the time to have a detailed discussion today. Really appreciate it. But before we get into the details of the topic for today, just wanted to take a step back and talk about the industry in general and how do we see the industry and where it is today. In my experience of about 8+ years being in the industry, I feel that there's been a huge transition from the way content was being consumed 2 years back to now, which means that from traditional linear channels, satellite TVs, to moving on to video streaming online in the form of OTT or IPTV. And it's really grown a lot in the past few years. The video streaming industry now it's valued at $89 billion, which is huge, and it is expected to grow further. And reports suggest that it will grow by 21% CAGR in the next few years. So, which is great. But as there is growth on the horizon, there are also challenges that the industry struggles with today. And there are a handful of challenges that we can talk about, like monetization strategy, content strategy, piracy, video quality. But today our focus is going to be on video quality and content piracy. Now, both of these topics are of paramount concern to platforms in the media and entertainment industry. Video quality, today's consumer is not willing to compromise on the quality of experience, and platforms really have to spend a lot on providing premium quality to the end customer. They have to pay a hefty price on the CDN side to ensure that the quality is on point in order to ensure stickiness. And content piracy, again, is a major concern because as people are moving to digital, there's so much piracy that is happening, and there are huge budgets assigned by platforms for content acquisition, and unauthorized way of distributing content affects content creators, distributors, and also viewers. So our main topic for today is to see how these two companies, Mylan Foundry and Inca, converge their technologies in an innovative way to to really address these major concerns in the industry. Anusha and Harish, what are your thoughts on the industry and the problems that the industry faces today?
Yeah, Mansi, as you rightly said, so today's topic, what we have as agenda. So we will be talking about the streaming issues, streaming content. So there is a lot of amount and resources put into the content generation, and when it is streamed, so it should be like a good quality, and the quality matters, and at the same time, like the profits. So how the revenue losses can be minimized by protecting their content, so that nobody takes illegal copy of it and does a restreaming of it or make money out of it, so causing a revenue loss. That is important. And then the quality, so they don't need the buffering sort of thing, so that they can watch the rich content and view most of the things. So that is most the industry is looking like. And other thing is like the cost cutting at the operation levels as well.
Agreed. So
Yeah.
you got a interesting point. Video quality can be defined as perceptual quality, but also QoE, which is quality of experience, and by which I mean that rebuffering, join time, latency, all these have become very important metrics for defining success for any platform. And we have Anusha joining us, and I would like for her to really introduce what this AI upscaling solution is all about, and how this helps improve quality, perceptual quality, and also QoE. Anusha, I would like to invite you over.
Thanks, Mansi. Mansi, if you can just switch to the slide uh, around. Thank you. Yeah, so I think, Mansi, you and Harish both touched on the quality of experience and why that's essential and important for streaming platforms of today. Um, we at Mylan Foundry really looked at this problem, and by the way, we are not the first to address streaming quality as an aspect, and there are many solutions that have come around in the last several years, including better codecs and better streaming pipelines and so on, which attempt to address this. But I think the right way to look at it is the fact that there are several of these factors, the fact that cost and rebuffer factors such as rebuffer ratio and video startup time and perceptual video quality and factors like latency, which don't necessarily work together. So you try and improve one, and you unfortunately have to compromise on another. So we sort of looked at the problem a little differently, and along with the realization that today's edge devices, so whether the client device is a mobile phone or a smart TV or a laptop or any of the other sort of edge devices that people today use for streaming, they uh, their processing capability has also significantly increased in the last several years. So we looked at it and said, why can't we use the processing capability on these edge devices to improve and alleviate some of the challenges? So the solution that we came up with is a real-time edge AI component that upscales and enhances the quality of the video sitting right there on the client device. So right before the video gets rendered onto the screen for the user, we are able to provide an improved quality of experience for the user. What this allows streaming platforms to do is that they don't have to stream at high bitrate, high resolutions anymore. Right off the bat, that saves costs. This also allows us to simplify the streaming process itself. So we don't need to encode so many versions of the video, because now we can guarantee a certain high quality of experience for the user without needing so many rungs in the bitrate ladder, so to speak. And that also provides improvements in the other factors that contribute to QoE, including video startup time, latency, and rebuffer issues. The way that we're able to achieve this is our AI models have been built to be extremely efficient. They have been trained with a very wide variety of content, so they're able to work with different types of videos, different genres, and different encoding, different origin, and so on. And they are able to provide this quality improvement across a wide variety of use cases. And we have particularly focused on efficiently deploying this across a wide variety of devices as well, because that's another challenge, is that when we talk about edge-based solutions, the biggest challenge is that you have to deal with a diversity of devices. So we've particularly focused on that and optimized a solution so they work across a wider range of devices, providing better device coverage and more value to our customers.
Yeah, that was going to be my question, that how do you ensure coverage? There is a huge variety of devices out there. So how do you ensure coverage? So are almost all devices capable of running such solutions, if I may ask?
Most devices today come with reasonable capability in their GPU. Reasonable capability in both their CPU and their GPU, but particularly GPU because that's relevant for AI workloads. Additionally, many devices today also have dedicated AI processors, and where we do have those kinds of resources available, we run our models on those dedicated processors. They could be NPUs, DSPs, TPUs, and so on, which are built for not just AI workloads, but for efficient deployment of AI workloads while minimizing impact on other parameters like battery consumption or memory usage and so on. Our module is device aware, so they seamlessly work across devices. So we know as soon as our module or SDK gets deployed, we know what the device characteristics are, and we are able to tune and pick and choose the right models and the right target processor unit to be able to run these AI workloads efficiently.
Interesting. And what about updates? So, if you have to update this SDK, typically, at least if I was to speak about India as a geography, it would take anywhere from 3 months to forever for a viewer or a customer to update the application. So how do you then ensure seamless functioning of the SDK?
Right, so we have a couple of different modes for making sure that we stay current and relevant as OS evolves, as devices evolve. One of the things is we allow for over-the-air updates of our modules. So our models can always be the latest and greatest that we're able to provide customers. So configuration on our models, they can all be changed as over-the-air updates. We also provide updates and we make sure that our SDK stays current with the latest OS versions, the latest player versions, and so on. And that can typically be bundled along with app updates every once in a while when they do happen. So we try and tie them along with customers' update schedules and make sure that we stay current.
Thanks, Anusha. Anusha, if I may ask, since it's a client-side deployment, what would be will there be any impact on the battery or memory? And if yes, then what would it be like?
For memory, actually, we are highly optimized and highly efficient. Our models, because they're meant to be running real time on a mobile or a TV processor, they're generally much smaller than models that you would typically run on the cloud. So they're highly memory efficient. We have in the last several years also optimized battery consumption, because that is a challenge for mobile devices specifically. So we've measured that over continuous playback of 1 hour of video. The additional battery consumption due to our module is somewhere between 3 to 5%, which is typically imperceptible to users.
Wow, nice. And when you say client side integration, it always raises a brow, right? Because it's typically challenging. So how would you define the integration process on your side?
Again, this is a specific aspect that we have worked on and optimized over our product development efforts. We typically insert our module into the video playback flow and specifically into the video player. And so we are compatible with all major video players. And especially with the ones that are the native players on each platform, our module has been built to be seamlessly integrated into the native player. So for example, on mobile phones or on smart TVs where there's Android OS, and XO player is typically the player that's used. We seamlessly integrate into XO player because it's an open source player, so it allows for us to develop our modules in sync with how it would typically be used in an OTT application.
Interesting. And do customers or platforms need to make any changes in the way they've designed their video workflow for this to work uh, or give the best results?
Yes, so that's the beauty of the solution, the way that we're doing an edge-based deployment of a video enhancement module is that it requires no changes whatsoever in the rest of the streaming pipeline. So our module is self-contained. If any information that it needs is available to it within the client side. And the way that we enable cost savings is also self-contained within the SDK itself. So that means it's a one-stop solution just on the client side that we're able to integrate and provide value.
Interesting. Interesting. Great. So that's a very interesting solution. We would want to also hear from Harish on the piracy side and then learn about how these two technologies are converging to address the problems discussed. Harish, over to you.
Thank you, Anusha, for great explanation on the AI-based technology that has been used for upscaling. And yeah, Mansi, when we talk about the content streaming, so typically there's a complete life cycle. Like the content gets during the pre-release, the post-production. So there can be leakages as any of those things. But the major other things for the OTT, what they are concerned is about like once the content is pushed onto CDN and they are rolled out. So there are typical different ways. The first thing is like the multi DRM is a must from the standard that needs to be applied. But even if multi DRM is present, there are ways wherein the content can be tapped and leaked and then redistributed via any of the piracy websites or the social media things. So it becomes mandatory now for all the Hollywood studios. They want to trace the piracy, like where actually who are the one behind this piracy, what is it happening, which regions the contents are being stolen off, and all those things. So we have created a workflow sort of thing where we provide a SaaS-based solution where they can OTT customers or any streaming customers want to encode, re-encode, transcode their content, apply watermark to a multi-DRM in a single workflow. But then the challenge with the forensic watermark is like the forensic watermark generates A and B variant. So typically, like when we want to have watermarking at scale, so we need to keep the watermarked content ready, and they will be mixed at the playback time. So it gives the advantage of scaling to millions, or based on the CDN, it can scale. So now
So,
there's a
Harish,
challenge. Yeah.
Harish, sorry to interrupt you,
Mhm.
but you mentioned a methodology. I just wanted to understand how many types of forensic watermarking exist today.
So as of now, there are two type of forensic watermark. One is like the server side watermark and the client side. So client side typically would sit onto the devices.
Mm-hmm.
like the set-top box or the mobiles. So on the client side, when the video is being played, with their unique ID, it would be watermarked. But this
Okay.
client watermarking has the issues of like integration, scaling up, and all. So wherein like when new devices come up, so those needs to be watermarked. The SDK or the module needs to be integrated with the player for watermarking and things like that. And it
Understood.
has its own integration time. So typically from the background where I come, I see like 6 months to 8 months to take to apply this client-side watermarking of different devices with its own challenges. And also we have seen there are sort of different attacks that can be performed
Oh,
to nullify this watermarking. So that's where we have focused on the server-side watermarking, wherein it's easily scalable, also traceable as well. So that is a advantage, and the cost also is like minimal for that. So now with when the only one challenge that we have with the forensic watermark on the server side is it will generate A and B watermark. Like typically if there is one stream, say 720p, it needs to be watermarked twice. So it will be 720p A and a 720p B, two watermark streams. So now if OTT stream has like multiple streams, which is SD, HD, and UHD, then it would be like six streams when they use the forensic watermark, which reaches their capital expense. And then they think that this solution is something uh, pricey and things like that. But now the beauty of this, whatever we have done, like the conversion. So with the AI upscaling, so we can reduce the number of streams, so that would reduce the cost for the operations as well. And at the same time, the watermark which is applied and is upscaled, we can still be able to detect the trace back the piracy who typically copied and redistributed the content. So typically we have this all server side SaaS based solution wherein you upload the content, the watermark is extracted, and we can reveal the identity of who the pirate was, or from which source, which device, which IP address the content was being leaked. And then the necessary action can be taken, like we can block those IDs, we can block in real time those streaming to that particular device and things like that. So that's how like the piracy tracking works with the forensic watermarking and the anti-piracy.
interesting. And how would you assess the robustness of a solution like this?
So, good question, Mansi. So, typically everybody asks like, how do you authenticate or how robust is the forensic watermark? So, for this, there is a body called as Cartesian. So, the Foncom security audit. So, it performs like 150 odd robustness test where they do different type of attacks on the watermark content, like rotate, crop, or change the resolution, re-encode it, and check whether we are still able to extract the watermark, which reveals the identity of the source. So we did score well, and we passed almost all the tests of it. And that is one of the main criteria. Not all the forensic watermark companies do show this certificate, but it's a challenge
Okay.
of the detection is the biggest challenge. So when the video get passed and it's
Hmm.
re-encoded or cropped and few other attacks, so it becomes typically difficult to get the detection. So that's where we have this certification, and we do provide like the demo page with the watermark, where anybody who wants to do a trial can extract the watermarked content, put it onto detection tool, and confirm our detection rate. So that is a typical thing that we provide, which gives more confidence on the robustness as well as watermark detection stuff.
Understood. And Harish, since you mentioned that since it's on the server side and the methodology around this is to maintain two streams, A and B,
Mhm.
this would also result in, you mentioned, increase of cost. So, how are you managing that, or can you give some idea on the cost estimates for a solution like this?
So basically, this forensic watermark embedding or detection, it's not the pricey one. So only the
Hmm.
cost that gets like the multiple streams that gets generated. Typically, that's the one
Yeah.
that is causing more operational cost. But there are ways like what we are discussing today, the topic, by upscaling it. So instead of multiple streams, if there is only one stream, then the cost is reduced. Plus, the watermark can be applied. So that is
Un-
one of the approach, like reduce the stream and then apply the watermark.
Understood. Understood. So this conversion presents an innovative response to the evolving
Yes.
demands of viewers and threats posed by pirates. But have you and Anusha, Mylin and Inca teams tried and tested this solution together?
Yes. Yes, typically what we did was like a 360p watermarked video was shared with Anusha's team. So where they upscaled it to 1080p and then captured the video content and shared with us. So, and when we ran our detection tool, we were able to extract the content out of it. So which clearly showed that our watermarking solution was very well preserved even in the upscaling stuff. And even with the 360p, which is like zero point 0.5 or 1x the reduce the cost of the CDN. So even with that, the watermarking can be applied, and we can backtrack the source of the leakage. So that's the typical theoretical concept we realized by actually doing it out with a joint demo sort of thing, joint POC. We did it, and we are able to confirm this theory about watermark applied to low resolution, upscaled, and we are able to detect out of it.
Interesting. Anusha, any points from you? Would you also like to share some points on this convergence of the two technologies?
Yeah, sure. I think Harish sort of explained this really well on how we thought about bringing two very different technologies, which you wouldn't think that there is any fit between something that addresses security and something that addresses cost saving. But
Yeah.
and I think this is the sort of innovation that the industry is really needing right now, which is a look at the system level, right? There are multiple challenges and they're all somewhat interrelated in the metrics that they impact, the business metrics that they impact, and the value that they are able to provide. So there is a need for these kinds of solutions which are looking at system level. How can we address more than one problem at one go instead of optimizing every single component individually? And I think that's the thought process behind our discussions when we started looking at what can we do together. And it's really elegant if you look at what we're proposing. It's almost as if the fit was really obvious, right? So the forensic watermarking solution that Harish talked about requires you to essentially double um, what you do on the streaming side. And what we are able to do on the upscaling side, we typically promise customers that we're able to reduce streaming costs and streaming bitrate and requirement by half. So it's almost like they were meant to come together in that way. And I think the proof is really in the pudding. So when we did this POC, we said that it's a nice concept on paper, but can we really prove that even when we have downscaled something back to 360p, where a lot of the watermarking information is somewhat reduced because you're reducing information, if I upscale it, first of all, does the upscaling do the right thing? And second of all, is that something that the detectors can detect? And it was really great that in the POC we found out that's exactly the case. We were able to upscale a 360p content to 720p. By the way, we can also do this with higher resolution, so we can go from 540p to 1080p. And it turned out that the detector was not only able to detect, and we were also able to show the bitrate reduction, and we were able to show the quality improvement as well. So, Mansi, if you go to the next slide, I think we have a video here that sort of shows, um, if you can play that.
Yeah.
Yeah, so this is a screen recording from a mobile phone. So it's a little small, but essentially the recording on the left is the original video, which was the 360p that Harish and team had provided to us. And the one on the right is where on an actual device, we did real-time upscaling and upscale the quality to 720p. And we typically are able to prove that we can replicate the actual 720p quality. It's not increasing the number of pixels, but it's matching the perceptual quality of what would have been streamed otherwise, which is HD. And so you will see the quality improvement, and the bitrate difference is roughly 50% between the two. And so the one on the right, the 720p, is what we provided to the detector and Harish's team. And it was able to easily detect the watermark present in the content.
Thanks, Anusha. This is a very innovative way of addressing the industry challenges. Is there a way for the viewers to find this some case study or white paper on the convergence of these two technologies?
Yeah, Mansi. So we have published this result, the white paper on our blog section on the PallyCon website. So where the customer can check how this solution can help them reduce the cost as well as apply the forensic watermarking.
Great. For any other questions, they can always reach out to Mylan Foundry or Inca. We'll publish the contact info underneath this video. Thank you.
Yeah, thank you. It was nice talking to you, Mansi and Anusha for.
Likewise. Thank you so
Thank
Thanks,
much.
you.
thanks,
Thank
Mansi
you.
and Harish.
Thanks.
Thanks
Thank
for the
you.
discussion. Take care.